Welcome to Sahel's Eduso. Today we are going to discuss about chemical reactions, speed of reactions, key objectives. To know the factors that affect the reaction rate, to be able to explain the effect of temperature and concentration on reaction rate in terms of the collision theory, to be able to describe a practical method to investigate the speed of a reaction that involves the evolution of a gas, to devise suitable methods of investigating the effect of given variable on reaction rate, to interpret data on reaction rate, to be able to describe the danger of explosive combustion with fine powders and gases, to be able to describe the effect of light on reduction of silver salts in photography and on the rate of photosynthesis. Discuss one by one. Reaction rate. Reaction rate is defined as concentration, change in concentration of a reactant per time. The best definition of reaction rate is rate equals change in concentration of a reactant per time. This emphasizes that rate depends on concentration and not on the amount of reactant. Once again, rate equals change in concentration of a reactant per time. Collision theory. For a chemical reaction to occur, reactant particles need to collide with one another. Not every collision results in the formation of products. For products to be formed, the collision has to have a certain minimum amount of energy associated with it. This minimum amount of energy is known as the activation energy, EA. Collisions which result in the formation of product are known as successful collisions. According to collision theory, the reactant particles must collide with each other. The successful collision leads to the product formation. The minimum amount of energy required to start up a reaction is called activation energy. There is a graph shown, y-axis energy, x-axis rate of reaction mentioned, reactants turns to product, there is activation energy shown on the graph. Now the factors depends rate of reaction, particle size, concentration, temperature, catalyst, pressure. First of all, we will discuss about particle size. This only affects reactions involving solids. A fine powder has larger surface area than a single number of the mass. That means if particle size increases, rate of reaction also increases. Simply we can say particle size is directly proportional to rate of reaction. The larger surface area increases, the collision rate increases. Hence, the rate of reaction increases. If we increase the surface area, there is more particles. So, particles collide each other. The number of collisions are more. So, effectively reaction will take place. In an industry where there are fine combustible powders such as coal dust in mines, there is a real risk of an explosion because there is a rapid combustion of the powder. In addition to that, there is a hazard takes place in coal mines because there is a release of methane gas is there. It will mix and there is a chance for explosion. Second one, concentration. As we increase concentration, rate of reaction also increases. When the concentration is increased, the rate is increased. Increasing the concentration of reactant, increasing the number of reacting particles in unit volume. That means in concentrated medium, the number of particles are more. So there is more effective collisions will take place. Due to more effective collisions, the reaction rate will increase. Increasing the concentration of reactant increases the number of reacting particles in unit volume. So the collision rate will increase as well as the rate of reaction also increases. Next one, temperature. As we increase the temperature, rate of reaction also increases. If we increase the temperature, the particles gain more kinetic energy. If they are getting more kinetic energy, they rapidly move. Due to their rapid movement, there is a more chance for effective collisions. Due to more effective collisions, rate of reaction increases. When the temperature is increased, the rate will increase and the rate will decrease when temperature is decreased. When the temperature is increased, the particles have more energy, so more of the colliding particles will have the necessary energy to react. Also, because the particles are moving faster, they will collide more frequently. The collision rate has been increased. Both of these explanations are valid one. Next one, catalyst. As we know, catalysts are substances which alter the rate of reaction. They are ready to increase the rate of reaction, but they do not take part in a chemical reaction. Catalysts have a surface on which reactants can settle and join together. The catalyst increases the chance of particles meeting and so increase the rate of reaction. Once the particles have met and joined together, they move away from the surface of catalyst. That's why we mentioned catalysts do not take part in reaction. They just only create an ambience for reaction. This leaves room for other particles to join together. Some examples of catalyst. Metals, nickel or platinum is used in hydrogenation reaction. Iron used in Haber process. Haber process, all we know, hydrogen combines with the nitrogen to form ammonia. Rhodium or palladium used in catalytic converters. We will discuss later. Oxides of aluminum, that is aluminum oxide, is used in dehydration reaction. Vanadium pentoxide used in contact process. Contact process, extraction or manufacture of sulfuric acid. When we are using catalyst, mainly we are using finely divided condition. That means powdered form, because it increases the surface area. There will be more effective collisions will possible. It acts as a supporting medium because to maximize the surface area. Using catalyst in laboratory. Hydrogen peroxide H2O2 is a liquid that very slowly breaks down into water and oxygen. It's a slow reaction. We want to increase the rate. To increase the rate, we are adding a catalyst. That catalyst is manganese dioxide. After adding manganese dioxide catalyst, the reaction rate becomes fast. Hydrogen peroxide is a liquid that very slowly breaks down into water and oxygen. However, the rate of reaction can be greatly increased by adding small amount of manganese dioxide. The reaction becomes so fast, the liquid fizzes as the oxygen escapes. Catalyst and air pollution. Car engines produce a range of gases. We are using fuel in car. This fuel burns and releases certain gases outside. Some of them, such as carbon monoxide, oxides of nitrogen, and hydrocarbons, are harmful. The catalytic converter is a device used in cars as a part of exhaust system. This catalytic converter converts harmful gases to harmless ones. Inside the converter is a catalyst made of platinum and rhodium. The waste gases from engine take part in chemical reaction in the converter, which convert harmful gases to harmless one. Here is an image of catalytic converter. The reaction takes place in catalytic converter. Carbon monoxide, it's a highly poisonous gas, react with oxygen to form carbon dioxide. Nitrogen oxide combines with the carbon monoxide to form nitrogen and carbon dioxide. Equation 2NO plus 2CO gives N2 plus 2CO2. The reaction takes place in catalytic converters are, first of all, carbon monoxide converted to carbon dioxide, oxides of nitrogen converted to nitrogen. Next, pressure. The pressure only affects reactions involving gases. As we increase pressure, the reaction rate increased. When the pressure is increased, the gaseous molecules become more closer, so they collide each other. Because there is less area, more effective collisions will take place. Due to more effective collisions, the rate of reaction. Measuring rate of reaction. In chemistry, the rate of reaction is studied by considering the rate at which the chemicals in the reaction change. Rate is a measure of change in a certain amount of time. The rate may show how much the mass of reactants changes in certain amount of time, or how much product is produced in certain amount of time. Change in mass of reactant. After the mass of reactant, marble chips and hydrochloric acid mixed together has been recorded. The reactants are mixed together in the flask and their joint mass recorded. The mass is then recorded regularly over a certain number of minutes. The word equation: calcium carbonate react with the hydrochloric acid to form calcium chloride, carbon dioxide and water. Once again, take marble chips and hydrochloric acid, record the mass of reactants. Then after every interval of time, regular interval of time, calculate the mass. Then you can calculate rate of reaction. First of all, you want to calculate the mass of marble chips and hydrochloric acid. After that, the reaction started. Calculate the mass in every regular interval of time. Then you can calculate the rate of reaction. The curds are put into steel or wooden drums and pressed and allowed to dry and are very distinct, and they are lose their shape as if they were very attractive forces of attraction. In industry, enzymes are used to bring about reactions at normal temperature and pressure that would otherwise require expensive conditions and equipment. Successful processes using enzymes need to ensure that the enzyme is able to function for long periods of time by optimizing the environment. The enzyme is kept in a place by trapping it on the surface of an insert solid. Some processes immobilize the enzymes when the process is complete. Continuous processes occur rather than batch processes. This PowerPoint based on the following syllabi: IGCSE, GCSE, CBSE, ICSE, State Board exams. Thanks for watching. Please subscribe our channel for further videos.